Okay, so we have to find the input impedance of the following circuit, and we're told that the angular velocity is 50 radians per second. So to find the impedance of this capacitor, it'll just be 1 over J WC. So this is in millifards. So so in fards, it's just 0.002 fards. Times it by the angular velocity, 50. So the impedance will be the impedance will be 1 over J 0.1. Okay, so 1 over 0.1, that's just 10. And then if we times the top and bottom by J, we get negative J10. Now the impedance value for this resistor is just 3. And this capacitor also follows the same principle. So J, the capacitance, which is 0.01 times W. So that's just 0.5. 1 over 0.5, that's just 2. We can bring the negative to the top by timesing both the top and bottom. So it's just minus J2. Now the impedance for this is just 8. The impedance for this inductor, it's going to be J WL. So 50 and then 0.2 henries. And that gives you J10. And all of these are in ohms. Okay? So this many ohms, this many ohms, this many ohms, this many ohms, and this many ohms. Now we see these two are in a series, so we can add them up. So we'll combine them and call this 8 plus J10, or 8 plus 10J. And then these two, they're in a series as well. So we'll combine them up, call this 3 minus J2. Okay, and these two, they're in they're in parallel. So it'll be 1 over. This is not a minus, sorry. It's just supposed to show that that's what it is equal to. Okay, so it'll be 1 over 3 minus J2 plus 1 over 8 plus J10 to the power of minus 1. Okay, now we can put this into our calculator by having it be in imaginary mode. So 1 divided by 3 minus 2 shift I plus 1 divided by 1 divided by 8 plus 10 shift I, and all of that to 1. And then you get your real part, and then you press shift equals to get your imaginary part. Alright, so now this circuit pretty much simplifies to just this, with this value being 3.2216 minus 1.0702J. And then this and this, they're in series. So we just add this and this together. But we only have the imaginary part for this, so we can only add it to this. So let me see what that gives me. I get minus 11.0702J. And this is your impedance value, your input impedance. So this is what Zn is equal to.